So you were asking about the window size. First of all, system will divide its facilities in, I don't know, can I explain it, but imagine this. You've got a way that, for example, you can take 3,000 bytes each time. You can send it, okay? So you will consider it as a window size, okay? And you're going to send the half parts first, then the second half. So the window size is 3,000, so you're going to send 1,500 bytes each time. It means 1,500 bytes, okay? So sequence 1 sending 1,500, and then it will send another one, and system will acknowledge that I will receive the first 3,000. Then it will be acknowledged for receiving 3,000. Then the sequence will start from 3,001 and start sending 2 different 500 bytes, and it will send. And after that, it will say that I didn't receive one item, so they just deduct the window size to half. It means 3,000 divided to half means 1,500,000, and then it will be sending the information again with the size of 750. 750. So this is the way that how we divide the window size to reduct, to prevent these kinds of data loss. So this is for the last session. Any problem on this framing? Okay. So can we start the rest? Today we're going to talk more about IP address. So there are just some slides. I just want to go as quickly as possible. So we've got IP phone, senders, video streaming here. We've got a network, and we've got a receiver for this one, video streaming for this one, and the other IP phone for this one. This is the UDP low overhead data transport. It means that we don't have that much information to send. We don't have the acknowledge, we don't have window size, we don't have nothing. We just divide the information in some smaller part and transmit it. Is that right? That's right. Is that right? For the UDP, as you can see, 1, 2, 3, 4, 5, 6. And in here will be 1, 2, 3, 5, 4. We don't have 3, we don't have 3. Yes, that's all. We don't have 3, and they are not in order. We are not going to reorder them again, and we are not going to send the packet number 3 again. So that's lost, and it's not on the order. So we don't need to get back again and find that packet. Or little bit packet, I can say.
We resend all the packet. Okay.
Yeah. We just divide them into 6 parts and transmit it in the UDP. And as you know, because we are using different routes, it could be reach the destination out of order. So we are not going to reorder again. This is the difference between TCP and UDP. Any problem?
Does it always occur in the...
No, most of the time it's not the same, but it is possible. So you have to know that some data may be lost. You know, we are going to increase our broadband. So lots of these kinds of, it's not a mistake, it's a characteristic of the UDP. So lots of things like that will happen, but we're going to increase our broadband, you know, using high-speed devices and things like that. So the amount of this missing information or, I don't know, disorganizing will be much more lower, but it's still existent and it could be happening. It's not TCP, so it could be happening. Any problem? UDP server listening for request. This is server. We've got 2 clients here. Describe how servers use port and numbers.
Excuse me. In the back page, I can't understand what here.
When
not
you're,
have a C.
it's lost.
Right.
Why? It's lost. It's because, I don't know, like the thing that happened in here. The internet connection has been terminated for just 1 second, so you lost 1 packet. It's just lost, you know. Have you ever sent an SMS and it's not delivered, or maybe it's just some part or the, no, not all of it, so some parts are missing. In TCP, we are going back again and ask, I didn't receive number 3. So we are in TCP, we are going to check. 1 is here, 2 is here, 6 is here, 5 is here, 4 is here, we don't have 3. So it will say in here that I didn't receive the file.
Acknowledged.
Yeah, in acknowledge part. In acknowledge, they will say that I received it or no. But in GDP, we don't have any acknowledgement. He just send the information. Some of them may be lost. It really depends. Maybe it never happens, but it might be happening. So, describe how servers use port numbers to identify a specific application layer. This is server application. DNS client request will be received on port 53. So, if it is DNS server, he is not working on port number 80. He is not working on port number 531. This is for HTTP. This is for instant messaging and things like that, is it? So DNS server got lots of ports, as you know. The systems got lots of ports, but it just listen to port number 53. If you want to resolve any naming system and asking DNS that, for example, I need to have google.com, you have to send it, your information to port number 53.
Defined.
Yeah, this is defined. For DNS, this is defined. The same as HTTP, that's defined at port 80. It means that if you don't know where to send your information, there won't be any answers. This is for security. Okay?
Port means switch.
Sorry?
Port means. What's the port means?
Port?
Switch.
No, port is like a window for some building, like a room number. For example, we are in port number 5206F. It means in the BTH camp, room number something.
Where specified.
Yeah, something like it is something like that. It's not really room or window, but we can just make an example and consider them as a room and things like that. And the radius clients need to send the things on port 1812. So those are the ports that you should know. But it's not that necessary, so you can find it through the net. So this is DNS server. So you should send your request to port 53. So if you're going to send your request, your source is port number 53. It means that you're going to send DNS request, and your temporary destination port will be 49152. It's temporary. It doesn't really matter. This one is just valid for this session. Okay, after that, it will be terminated. Okay? Just a sample. And the same for